Today's topic is double integrals in polar coordinates. So there is no difference. Only thing is that up to now we were calculating, we were integrating the function of two variables x and y. Now we have a function of r and theta. So I hope you know what are the polar coordinates. Means suppose this is your suppose this is your point in xy plane, means Cartesian form, xy axis. So this is point, suppose xy. So this is the Cartesian coordinate, and if you find out the polar coordinate of this point, then this is from origin to this point a line is there. This is called r radius, and the angle from positive x-axis to the radius, uh, and this is called theta, and this is in the anti-clockwise direction. So this in Cartesian form, this point is xy, means the x length and the corresponding y length. So this point is going here to here and here to here. So in the Cartesian form, this is xy, but when we write this in polar form, this coordinate in this point is r theta. So what is r? R is the distance from origin to that point, that diagonal distance, and that angle theta is this is the angle which is from the positive x-axis to that point. So this is theta. So either we write xy or r theta. So xy is in Cartesian form and r and theta is in polar form. So the notation is different. So now we will evaluate the double integrations in polar form. So what is the function? Now the function is in terms of r and theta, and the limits are with respect to r and with respect to theta. So there is no difference. Means अभी तक हम क्या कर रहे थे कि हम एक डबल इंटीग्रेशन निकाल रहे थे जिसमें दो लिमिट्स थी, एक x की लिमिट्स थी, एक y की लिमिट्स थी. अब हमारे तो फंक्शन भी xy का था, इंटीग्रेशन विद रिस्पेक्ट टू xy थे. अब हमारे पास क्या है, जो फंक्शन है वो r थीटा के फॉर्म में होगा, तो इंटीग्रेशन भी dr थीटा थीटा के फॉर्म में होगा, और जो लिमिट्स होंगी वो भी किसके होंगी, एक r की लिमिट होंगी, एक थीटा की लिमिट्स होंगी. तो आपको बस ये पता होना चाहिए कि सपोज कि ये हमारा पोलर कोऑर्डिनेट बनते कैसे हैं. सो दिस इज योर एक्स वाई प्लेन. सो अगर आप ये पॉइंट की बात कर रहे हैं तो ये कार्टेशियन फॉर्म में क्या होगा, ये एक्स लेंथ, क्लियर, यानी ये वाली एक्स लेंथ और ये वाली वाई लेंथ. ये क्या है, वाई लेंथ है. सो ये एक्स वाई बनता है. बट अगर पोलर फॉर्म में बात करें तो ओरिजिन से लेकर इस पॉइंट तक की जो डिस्टेंस होगी उसको हम आर से डिनोट करते हैं, और ये जो एंगल बनता है पॉजिटिव एक्स एक्सिस से यहाँ एंटी क्लॉकवाइज इस पॉइंट तक, तो वो क्या होता है, थीटा. तो इसको हम क्या लिखते हैं, आर थीटा फॉर्म में लिख सकते हैं. ठीक है. सो दिस इज पोलर फॉर्म. तो हमें थीटा की लिमिट्स चाहिए कि थीटा कहाँ से कहाँ तक वेरी कर रहा है इस रीजन में, और आर कहाँ से कहाँ तक जा रहा है. मिनिमम वैल्यू आर की पॉसिबल क्या है, 0, और मैक्सिमम कहाँ तक जाएगी, इस पॉइंट तक. तो हमें दो लिमिट्स फाइंड आउट करने, एक आर की लिमिट्स और दूसरा थीटा की लिमिट्स. सो दो फॉर्मेट हो गए. अगर कार्टेशियन फॉर्म में जैसे हमने क्वेश्चन सॉल्व किए हैं वैसे ही आपको पोलर फॉर्म में सॉल्व करना है. क्लियर. तो लिमिट्स आपको फाइंड आउट करनी है कि आर की है या एंगल की है. तो जहां वैसे देखते हैं कि इनिशियल अगर थीटा के टर्म्स में लिमिट्स हैं तो आर की लिमिट्स होंगी, क्लियर, और थीटा ऑलवेज कांस्टेंट होगा. यहाँ ऑलवेज एक चीज फिक्स है कि आर की जो लिमिट होगी वो थीटा के फॉर्म में होगी, बट थीटा ऑलवेज कांस्टेंट होगा. तो पहले हमें आर के रिस्पेक्ट में करना है इंटीग्रेशन, फिर थीटा के रिस्पेक्ट में करना है. क्लियर. So this is the double integration in polar coordinates. So we always take this integration. First we will integrate this with respect to r, and then we will integrate this in terms of theta. Clear? So like this question, we have to evaluate double integration r sine theta dr d theta over the cardioid r is equal to a 1 minus cos theta above the initial line. So this is, I think, I hope you know what is the structure of cardioid. R is equal to a 1 minus cos theta. So this is this type of curve, and this is positive x-axis. So above the initial line, this theta is equal to 0 or x-axis is called initial line. So this is theta is equal to 0 is initial line. So we have to find out this integration over the cardioid above the initial line, means above the initial line means this area. Clear? So this area here we have to find out the limits. So limits, first we will find out how r varies in this region. So what is r? R varies from 0 to that curve. So this is r is equal to 0 on this line, and you are going towards this curve. So r varies up to this curve, that means this curve, and this curve is cardioid. R is equal to a 1 minus cos theta. So the minimum possible value of r is 0. So here on this line r is 0, and when we go up to here, so we either we go this side or any side, the upper limit of r will find out on this curve. So this curve is r is equal to a 1 minus cos theta, and minimum value is minimum value of r is 0. And for polar coordinates we always take the limit, first limit of r, then the limits of theta. So r, the minimum value of r is 0, the maximum value it is going up to that curve cardioid, r is equal to a 1 minus cos theta, and next theta. So in this curve, this is our region. So theta varies from, because what is theta? Theta is taking the angle from positive x-axis to that point. So the area, the whole area is this. So we always take theta. This, suppose this is your positive x-axis, and theta varies from here to that point. So theta varies from 0 to, we have to go to this point because this is our region. So theta varies from 0 to, what is this value? Pi. Clear? If the curve is from up to here, then the theta varies from 0 to pi by 2. If curve is going to here, then the theta varies from 0 to pi by 2 to next 2 pi by 2. So this is 2 pi by 2, that means pi. So theta varies from 0 to pi. So next, what is the function? R sine theta dr d theta. So our limits are 0 to r is equal to a 1 minus cos theta. So first we will integrate this with respect to r. So theta is constant with respect to r. So what is the integration of r? R is square by 2, and the limits are 0 to a 1 minus cos theta. Next, sine theta is as it is. Apply the limits. So you will get this function. Now you have to integrate this. Sorry, this integration. So you have to integrate now this with respect to theta. So how you will integrate? You find out 1 minus cos theta as t. So sine theta d theta will be dt. So t squared dt means t cube by 3. This is the integration. Now apply the limits 0 to pi, you will get this value. Now calculate this over the area included between the circles. R is equal to 2 sine theta, R is equal to 4 sine theta. So r is equal to 2 sine theta is this circle above the x line, and r is equal to 4 sine theta is this circle above the x line. So for this polar form, you need to know the structures of the polar curves. So till now we have not studied about the means this you will find out in the topic curve tracing. So if you know the curve tracing of the functions of the curves, then we can draw these curves, cardioid, the circles, anything. So using the concept in the means concept from the curve tracing, we can draw these circles. So for now you assume that r is equal to 2 sine theta is a circle above the x line like this, and r is equal to 4 sine theta is also a circle above the x line like this. So the area between these circles, that means our area is this. Clear? So now find out the limits of r and theta here. So this is our reason, this region. So again, you can observe that theta varies from 0 to this point, that means 0 to pi, and r varies from, because our area is this, so we have to take the r from origin. So if we draw from here to here, this is maximum line, and what is the minimum condition? Minimum condition is here. So r varies from this point to this point. Clear? The total r variation is the lower limit is here and the upper limit is here. So on this lower limit, this is the circle, r is equal to 2 sine theta. So the minimum value of r is 2 sine theta, lower limit, and the maximum it is going up to 4 sine theta. So this is your upper limit. So r varies from 2 sine theta to 4 sine theta, and theta varies from 0 to pi. Now you have to integrate this. So r cube, the integration is r4 by 4. Apply the limits. Next, so the limits, these are limits of theta, and you have to integrate this. So this is means you have not studied about beta and gamma function. This integration is very easy to calculate using gamma beta function. So I have written something here, that 2 0 to pi by 2 sine m theta cos n theta d theta. The value of this integration is beta m plus 1 by 2 comma n plus 1 by 2. क्लियर? क्या होगा? 2 से 2 इंटू 0 टू पाई बाई 2 साइन टू द पावर m थीटा cos टू द पावर n थीटा डी थीटा. इसका इंटीग्रेशन क्या है? बीटा m प्लस 1 बाई 2 कॉमा n प्लस 1 बाई 2. नाउ अब बीटा गामा फंक्शन अभी आपने पढ़े, तो आप केवल ये फॉर्मूले देख लीजिए क्या है. The beta mn value is gamma n divided by gamma m plus n. So this is gamma function. Now what is the value of gamma n? Gamma n is n factorial, m gamma n minus 1, or gamma n is equal to n minus 1 factorial. So if n is integer, positive integer, we will use this definition. Gamma n is equal to factorial n minus 1. That means suppose gamma 6 is factorial 5, gamma 10 is factorial 9. And if n is not integer, we will use this definition. Gamma n is equal to n gamma n minus 1. That means suppose gamma 5 by 2. So gamma 5 by 2 is 5 by 2 gamma 3 by 2. Now again using this same definition, gamma 3 by 2 is equal to 3 by 2 gamma 3 by 2. Clear? So gamma 5 by 2 is equal to 5 by 2 gamma 3 by 2, and gamma 3 by 2 is equal to 3 by 2 gamma 1 by 2, and gamma 1 by 2 value is square root of pi. So we have used this combination of formulas. So you have to remember this formula, because till now you have not studied about beta gamma function, but this will help you to solve the integration like this. So what is the value? 60 into integration of this. So the integration, the limits must be, it is 2 times 0 to pi by 2. So limits must be 0 to pi by 2. So first you have to make the limits 0 to pi as, so we have multiplied 2 and make the limits 0 to pi by 2. Next, this is of this type, 2 times 0 to pi by 2 sine to the power 4 theta, and this is sine theta to the power m. So the cos theta to the power n is not here, so we can assume that this is cos theta to the power 0. So m is 4, n is 0. So this is what, if you expand this, you will get the formula like beta 4, so 4 plus 1 by 2, that means 5 by 2, and this is 0, n is 0, so 0 plus 1 by 2 means 1 by 2. So beta 5 by 2 1 by 2. Now beta 5 by 2 gamma 1 by beta 5 by 2 1 by 2 is gamma 5 by 2 gamma 1 by 2 divided by gamma 5 by 2 plus 1 by 2. So this 5 by 2 plus 1 by 2 is 6 by 2, that means 3. So gamma 3 is 2, gamma 3 is factorial 2, so factorial 2 is 2, so denominator is 2, and gamma m is gamma 5 by 2, 5 by 2 is, using this expression, gamma 5 by 2 is 5 by 2, 3 by 2, gamma 1 by 2, and gamma 1 by 2 is square root pi. Similarly, gamma n is 1 by 2, gamma 1 by 2, and gamma 1 by 2 is square root pi. So whenever you use this combination, you will get this answer. So now you have some problems of double integrations, change of order of integrations, and the polar forms, double integration in polar form. Clear? Now the next topic is area enclosed by plane curves.